Today, I'm going to be presenting on the research we've been working on to improve question answering on financial-based documents. All right, so overview of how the presentation is going to go. Just an overview of what RAG is and why we need it, and then the problem for our specific use case, and then we're kind of go into why RAG currently has a lot of limitations, and then the different strategies we're trying to make it better, and the different ways we're going to try to evaluate of how good our RAG systems are so that we can basically tell whether or not we made improvements. Oh, shit. So for us to what RAG is, it's basically a way of knowledge injection for large language models. So LLMs are limited by their training data, usually. So if you want to ask it information on things that are like more recent or not in their training data, they won't know it, and that can lead to like things like hallucinations. And the two main ways to kind of add additional knowledge to large language models is with like fine tuning or like in context learning, and RAG is a form of in context learning, where in this method we're not actually changing the model parameters with additional training like we would be in fine tuning. We're just kind of adding additional information into the query itself or to the input of the LLM so that it'll have like this additional knowledge to refer to. And the way that it adds this additional knowledge is through this thing called a knowledge hub, which is made up of like knowledge sources. And this kind of diagram explains how that happens, where the user will ask a question and that question is converted to embeddings, which are numerical representations of the text. And we do a similarity search through the vector database. And this vector database basically just has all the information of the additional knowledge you want to add to it. So if you want to chat with financial documents, the vector database has embeddings of all that information. And based on the similarity search, it'll retrieve the top K chunks, and then that will kind of be the context where it'll feed in directly to that large language model. So it'll be like, I have this question, answer this question using the following context. The context will be from the knowledge sources, and then the LLM will have all the information it needs right there in order to answer the question accurately. And because the information is put right there, it's very effective in preventing hallucinations because it'll have access to the information, so it won't have to make up additional things. However, kind of like the basic way of it works, while it's good and effective for like maybe simple use cases, as you want to get more complex, there's a lot of like limitations.